Hello, this is the genuinely approachable Sudoku for the 11th of March 2024. It is Fog Killer by Bill Murphy, featuring killer cages but also fog. So let's look at the rules of the puzzle. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Digits in cages must sum to the given total. So you have cages here, for example. The digits in those cages must sum to whatever is here. So those digits sum to 15, for example. Those digits sum to 6, for example, and so on and so forth. Correct digits will lift the correct placed digits will lift the fog across some cells in the grid. So yeah, here you can see there are a bunch of cells here. If a correct digit was placed here, like a 3, for example, if this was a 3, then all the fog around it will be removed, allowing to see what's underneath. So yeah, those are all the rules. With that, let us just begin solving. Now, this particular puzzle does involve a trick that we were supposed to learn in a previous puzzle, that is the 14, 15 or 5, 6 cages. Notice how when you add them together, you get a sum of 11. So those 4 digits sum to 11, and 4 digits sum to 11 does in fact have a very specific combination. They must be 1, 2, 3, and 5. And you can prove that by showing that, well, the minimum in a box must be 1, 2, 3, and 4. The minimum digits you can put in the box is 1, 2, 3, and 4. That adds up to 10. To make it an 11, you need to increase amount of digits by 1, but you cannot repeat them because digits may not repeat in the box. And so you cannot increase the 1 by 1 because then you have 2 2s. You can't do the same for 2 because you have 2 3s. You can't do the same for 3 because then you have 2 4s. And so the only digit you can increase is the 4, which gives you 5. So this is the only combination that can fill this 5 and 6 cages. Now notice, where does 3 go in this cage? It can't go with the 6 because if it was in a 6, the other digit would have to be a 3 as well to make 6, which doesn't work because you can't repeat digits. Meaning the 3 must go in the 5 cage and must join with 2 to make 5. The remaining digits have to be 1, 5, which do in fact add to 6, so that works out. Next. Next, the 14, 15 is a very similar idea, where if you add them together, you get a total of 29. The maximum you can place in 4 digits in a box are 6, 7, 8, and 9, which add up to 30. To get 29, you must decrease one of the numbers by 1. And you can't do that for 9, 8, and 7 because those will all give you repeated digits. The only thing you can remove is 6, which then gives you a 5. So this is the only way to get 29 in 4 cells, which must fill this. Now, where does 7 go in this box? It cannot go in the 14 cage because you need another 7 to accompany it, which doesn't work. The 7 must go in the 15 cage, which must have an 8 to accompany it. Therefore, 5 and 9 go in the 14 cage, which works out. Alright, next. Now we have this. We could probably try looking at the rest of the cages as well. The 14, for example, because of the 1-5 pair here, the 14 cannot have a 5 in it. And because 14 we know only has 2 options, it can only be made of 5, 9, or it can be made with 6 and 8. Those are the only 2 ways to make 14 in 2 digits. The 5 in this row means that the 14 can be made of 5 and 9, they must be made of 6 and 8. We can do the same in the top right corner. The 6 can only be made with either 1, 5 or 2, 4. The 5 in here removes 5 from the 6 cage, which means it cannot be 1, 5, it must therefore be 2 and 4. We can disambiguate both of these pairs because of additional pairs we have here. The 7, 8 pair removes 8 from that cell, giving us a 6 here, and therefore an 8 here. The 2, 3 pair removes a 2 from that cell, giving us a 4 there and a 2 there. Right, we have more cages to work with now. The 4 cage is very useful. 4 can only be done in one way. It is only 1 and 3. And the 1, 5 here removes 1 from that cell, so that's 3. 1 goes up here. This 16 cage can only be made of 7 and 9. 9 in this row cannot be there, so that must be a 7. 9 must be below. It reveals an 8 over here. Okay. Well, I don't know how to continue with this, but probably can do some more stuff. Like how 11 is filled, maybe? Yes, because 11 actually is very restricted here. It can't be 2 and 9 to make 11. It can't be 3 and 8 because 3 is in one of those cells, which always sees both of those cells. it can't be 4 and 7, and therefore can only be 5 and 6. That resolves this 1-5 pair down here. Cool. Alright, I believe we're starting to deviate a little bit from here because there's a fork here which we can't lift just yet. But okay. Maybe this 8 helps us? Well, I guess the last 3 digits in here are 1, 3, and 8, right? And 8 clearly can't be in the 8 cage because you can't have 0 in the other cell. But what that also means is that this digit can't be 1, because 1 must be paired with 7, which already exists in the column. So this cannot be 1, it must just be 3, which must be accompanied by 5 to make 8. Nice. Okay. Those digits do add up to 8 as well. However... However what? Well, I can say that those digits are pretty special. Yes, because in this column, 1 and 2 cannot be in those cells. We know the 1 and the 2 are in those cells and therefore cannot be here. 1 and 2 therefore enter those cells and form a 1-2 pair. This digit, as a result, is either a 6 to pair with a 2 or a 7 to pair with a 1. Actually, those also form a triple. That's how we get in. Those digits are 1 to 6, so the last 3 digits here are 7, 8, and 9. That removes a 7 from this cell, and therefore this cell must be a 6, which gives us a 2 here to make 8 and a 1 down there. 7, 8, and 9 do have counterparts here. They are either 5, 4, or 3. However, the 5 here removes 5 from this cell, therefore this cell cannot be 7. That digit is also a 3 or a 4 to finish the box. And in fact, we have other stuff here we can do. That is either a 7 or a 9 to finish the column. And those digits are either 4, 6, or 8. Oh, that does help because the 6 and the 8 here remove 6 and 8 from that cell, giving us a 4 there. This digit now can't be 4, but it can't be 8 either because those digits come to 9 and 8 here would force a 1 there, which doesn't work. So this must be 6 beside 3. That digit is now an 8. We now have an 11. Well, 3 firstly resolves this 2-3 pair. Does this get resolved? I don't believe so, honestly. No. I guess we can do stuff with this. Oh yeah, we definitely can. Those digits have to be 2, 7, and 9 to finish the row, which does affect the 11 cage, because the 11 cage now cannot be made of 2, 9, 3, 8, because of the 8 and 3 here, or 4, 7, because 7 already exists in the box. So it must be made of 5 and 6. Those last 3 digits must therefore be 1, 4, and 8, I believe. And 1 can't be in those cells, so 1 goes up here. That resolves this, which should help, maybe. Well, 12 we know has a total of 3 options. They're either 3, 9, 4, 8, or 5, 7. 3 here removes 3, 8 from those cells. 3, 9, sorry, which leaves us with either 4, 8, or 5, 7. We know 8, 5 cannot be in those cells. And therefore, to finish up 12 here, I shall just remove those cells. The 4 needs to pair with 8, and the 7 needs to pair with 5, which gives us a couple more options as well here. This 4-8 pair allows us to finish a triple over here though. This has to be 5, 7, and 9. Right, 7 and 8 here remove 7 from that cell, which gives us, well, it gives us a 5, 9 pair, which is somewhat useful maybe. Not exactly sure what I can do after this, but probably some Sudoku I'm missing. Some like pair that I never actually realized was resolvable. Not right now, I don't see anything. I guess that is a triple or a quadruple of some sort, but I don't believe there's anything up there. I guess 6 maybe. No, 6 is in here. What am I saying? Yep, I don't see anything. Where else can we go after this? Maybe those two? Those are both 12s, which could help. The fact that they're both 12s means they have to be different different combinations, which I won't explain, but I don't think we used that in the first place, so I don't think that's a real need to explain. What's one thing that we did before? The 3s? Yes, 3 in this box. That is really easy, I just missed it. The 3's in this box must just be here, which resolves this one. Yep. This now can't be 2, 9 because of the 9 here. It can't be 3, 8. Could it be 5, 6 or 4, 7? I think both are available. However, the 5 and the 7 in this box remove 5 and 7 from those cells. That digit to make 11 is therefore either a 7 or a 5. Cool. This is very unconventional because... yeah, still. Alright, well, the 1 does help because the 1 in this box must now be here. Gives us a 10 here, but also resolves this 1, 8 here. This 8 resolves this 7, 8 here, which does not resolve this, but I will take it. Right, now the 10. Could we do anything with that? No, the 10 still has a lot of options. Yeah, in fact, it has a lot of options. No, this one's a triple though. I guess I could use that. Those have to be 2, 4, and 6. Which removes 4 from that cell. So that's a 7, meaning this must be a 5. Those are the 12 now, but can't have a 5 in it, so they can't be 5, 7. They could be 4, 8 or 3, 9, I think. But they can't be 3, 9 because the 3's here remove 9 from both remove 3 from both of those cells. So they must be 4, 8. And this 8 resolves that. 4, 8. 8 now can't be there. But also this digit is now a last digit, which has to be just 9 to finish the column. Those digits sum to 9. They can't use 1, 8. You can't use 2, 7. You can't use 3, 6. It must just be 4 and 5. Which resolves this. This is no longer a 5. That's a 7, which must be beside 4 to make 11. Those digits could also be useful because they can no longer be 1, 9, 2, 8 or 4, 6. They must be 3 and 7. The 7 here resolves that. 3 also resolves this 3, 4 pair. 7, 9 means that must be an 8, which resolves this triple we've been having. This 7 resolves this 7, 9 pair. And that digit is no longer a 7. That forms a pair as well, which we can in fact write on the fog, so that's useful. This is a 2 and a 4. And the 4 resolves that, so there you go. These sum to 9, the 4 must be with 5 to make 9. And that resolves this pair up top. 2 resolves this 2, 6 pair. And this 4, 5 resolves this 5, 6 pair here, that must be 6. This digit is just a 9 to finish the row. That forms a pair consisting of 2 and 6, I believe. Yes. And those last 3 digits are 1, 3, and 8. 1, 3, and 8. 3 can't be there, 1 can't be there. Similarly, 9 can't be here, 7 can't be here. Alright, so this looks very symmetrical so far. I could probably fill in the rest of this. That, for example, is just a 6. Those digits are 1 and 2, that is resolvable. Yeah, and this is very symmetrical. We can just fill in the triples for the rest. Those digits have to be 1, 2, and 6, I believe. Those digits have to be 3, 5, and 9. And those digits are therefore 4, 7, and 8. Yep. Okay, now how are we going to resolve all of this stuff? Well, let's start with 7. 7 can't be there. 3 can't be there. Actually, 9 can't be there either, so this is a 5. That is just a 5. Which should help because 5 resolves a lot of stuff. It resolves this 5, 6 pair, which moves up here to resolve this 2, 6 pair. This 5 we uncovered also resolves this 4, 5 pair, which proceeds to resolve this 4, 8 pair. So yeah, a lot of stuff going on. That now can be 8, giving us the classic chocolate teapot. 4 here means that is an 8 though, which resolves all of this. So we had that cheap that teapot existed for a very short amount of time. I'm sorry. Just moving a lot here. So 1's now come in those cells, so 1 must be here. 6 resolves this final 2, 6 pair. 4 here resolves this 4, 7 pair. And this last triple, 2 resolves the entire thing. 9 here means that's a 2. The last digit is just a 9. Yeah, solves the puzzle. Whoa! Doesn't include solution. Well, I hope I'm right. But solves the puzzle in 30 minutes and 29 seconds. So there you go. Hope you enjoyed this video. I'll see you guys next time. Bye bye.